So let's start. Okay, guys. So good afternoon. Yes.
You take the homework assignment in the lab.
Yes. Okay. Yeah. You have to print it, write your name, give it to us. Okay. Thanks. So good afternoon, everybody. So last time I told you any assembly program should have two things. That's what we write in any assembly program. We write directives. I told you directives means you have to write these are commands to the assembler, to the program. They are not converted to machine code. They are not going to be executed by the microcontroller. Okay. I explained org. I told you every program should have at least two orgs. One to tell the assembler where in memory you want to store your data. And usually you are going to do something like org 1000 and another org 4000. Org 1000 for the data. So I want to store my data starting from 1000. My code is starting from 4000. Okay. If you look at your code, you're not going to find 1000 and 4000. Instead, you will find something called RAM start and ROM start. But RAM start and ROM start are already defined. They are defined in the file you include. RAM start with 1000, ROM start with 4000 using equate. So they are defined this way in the file you include every time. So this file, let me. So in our program, we include this file here, this one here, we include it in our program. If you open this file, you will find this file. This file has just a definition using equate. I explained last time equate. Equate means every time I use this word in my program, please replace it by this number. So here, if I look for ROM start, yeah, so this is not. So if I look for example, RAM start, yeah, as you see here, guys, RAM start should be 1000. That's what I said. But if you look for what's called ROM start or something else, let me see. I think it's called ROM start. You can check the program. I think it's called the ROM start. Not this one. This is the only one we have here. Anyway, I will check the program to see but it's already defined here. I told you guys. So this is number one. Every program you have to use two orgs. You have to tell where you want to store your data in memory, and you have to tell where you want to store the code. You have to make sure they are separate. There is no overlap. You have to make sure they are in separate places. Makes sense, right? Because if I write here in the code, I'm gonna change the machine code, right? And this is gonna like my program is gonna crash anyway. So also I explain. Oh, sorry, you have question? I'm sorry. What comes to 1000? We have, okay, that's a very good question. Number one, the whole range, we have range from 0, 0. So the whole range we have from 0, 0, 0 until F. Okay, but as you will see later, we don't use the whole range for memory, right? Some addresses are used for input output. You got what I'm saying? Some addresses are used for EEPROM. We have EEPROM, we have RAM, we have flash. You got what I'm saying? So what comes before 1000, some addresses here are used for input output devices. Like for example, if I go here and search here, for example, port B. Okay, so if you see port B, it's at location number one. Is that okay? And I'm gonna explain later. Port B is connected to the LEDs. Okay, so some addresses are not for memory. Some addresses are used for EEPROM. You got what I'm saying? So I think if you search here, yeah, for example, yeah, this double E or EEB ROM should start from 400, as you see here. Okay. So also I explain we have some directives. We are going to use them to define variables similar to integer, float, or all these data type used in C language. But here it's much simpler. All what we have here, as I explained, dc.b, this one is used if you want to define a variable byte and initialized. Also, you can use the same keyword to create array of initialized bytes. Okay, and then if you change B to W, now it becomes for word. Okay, so again, and I said for word, every element here or every variable here is going to take two locations, as I explained last time. Okay. Also, I explained ds.b and ds for uninitialized. Okay. Also, last time I explained FCC. I told you FCC is used if you want to define a message. You define a message here so that you are gonna use it later in this course. For example, I wanna display a message here. Hello, please enter your name. I want to define a message. This message has to be stored in memory, and it has to be stored in ASCII code. Okay, so it's like an array of bytes, but every byte should store the ASCII of one character. Even a space has the ASCII of 20, right? That's why when I come to chapter 3, if you want to leave a space here, you have to send the 20, because 20 means space. You got what I'm saying? Every character, even space, has an ASCII. Okay, as also I explained. That's why you have to define this way. And I told you, you don't need to bother yourself to do the conversion from letters to ASCII by yourself. All what you have to do, just write English sentence like this sentence, and then what's going to happen is going to be stored here in ASCII. You got what I'm saying? So for letter E is going to come here ASCII, letter R, next one, letter R, next one, and so on. Even space is going to come here, right? If you leave two spaces, it's going to take 2 bytes. Every space is going to be 1 character, and so on. Is that okay? Okay. Yeah, I give you one example here. The last thing I explained last time, equate, and I told you equate similar to this one in C language. You just you wanna use every time you use English name like the word speed, so it's gonna be replaced by 20. This is when you convert it to machine code. Okay, that's what we call equate. And I told you in this course, the way you are gonna use equate is we hate using numbers. It's difficult for us to remember numbers. You got what I'm saying? So if you want to display something here on the LEDs, you have to use number. You have to use the address. If you want to get something from the keypad, you have to use a number. You got what I'm saying? But we hate numbers. What can we do? So what we did for every device here, I defined English name. And all what you have to do, just use the English name, and it's going to be replaced by number. You got what I'm saying? By the way, this is similar what we do when you serve the internet. For example, when you say www.tntech.edu, for example, or if any website, what happens is that you are going to use English name, but actually this name is going to be replaced by the IP address. It's the same idea. Because for sure it's going to be too difficult. If you want to go a certain site, you have to remember numbers for the IP address. It's going to be too difficult for us, right? We like English words, and it's the same idea. So whatever you write here in English is going to be replaced by a number. We're going to do the same thing using equate. Anyway, the last thing I want to explain here before I move to the next topic, and this may not be very important. We have another directive. We call it fill. So as you see here, this is how we can use it. I don't think we're going to use it in this course, but that's okay. I'm going to explain how can we do it. So fill, for example, I can say fill, and then I'm going to put here a number, and then I have to say how many locations here, 40 locations. What happens here, this directive, you are going to store this value in 40 locations here. So when you say this one, I'm going to start from 1000 here, and then I'm gonna fill 20, 20, 20. How many bytes? 40 bytes. Is that okay? Anyway, so this one is used if you want to put a certain number in many locations. Anyway, I don't think we are going to need it, but this is one of the directives. Any questions? Yeah, sure.
What if we want to fill that number in a specified set of locations?
Yeah.
But how would we specify the starting location?
You have to write instructions to do that. I'm going to teach you instruction. One of the instructions, you can write in a specific location a certain number. You got what I'm saying? Similar to what you did in C language. In C language, when you say I is equal to 20, you got what I'm saying? I here has a physical location, like for example, 1000. So you can, yes, I'm going to teach you later some instruction so that you can write any number to this physical location. You got what I'm saying? So we will do that. So now I want to move to the next topic. I told you before, any assembly program should have directives. I finished directives. You should understand now what kind of directive we are going to use. I told you tomorrow there will be a quiz. This quiz is on, it will be similar to the example I had here. For example, it will be something like this example here, guys. I'm going to give you some directives here, and then I'm going to ask you to draw the memory this way. I just want to make sure you understand when I say org 800 or whatever, I'm going to start from 800. I want to make sure how this instruction or how this directive is going to be allocated in memory. Also, I want to make sure when I use A1 later or A2 or A3, what addresses are going to be replaced by A1. A1, as you know, is going to be replaced by this one. A2 is going to be this one, and so on, as I explained before. So nothing, no surprises. You're not going to see any surprise, but just if you understand what I explained, everything will be straightforward. All what I need from you to understand the lectures, and that's it. So I'm going to test you on what I'm explaining, okay? So now I'm going to move to the next part here. The next part, in any program, in addition to directives, we write instruction or commands, okay? Instruction, like for example, addition, multiplication, and so on. So that's what I'm going to teach in this chapter. I'm going to teach instructions. So these instructions are converted to machine code. These instructions are run by the microcontroller. Is that okay? So let's start with this here. Let's start it. Yeah. So here, guys, look here. In any programming language, every command or every instruction has to tell two things. It has to tell what operation you want to do. I want to subtract, I want to multiply, I want to divide. So you have to tell what operation. Also, you have to tell what operands you have to use. You got what I'm saying? So now, in this lecture, I'm not going to teach instruction, but I'm going to teach operands. How can you write? How can you express operands in assembly? So that's what we're going to use in the instructions. So tell me, what do you mean by operand? What operand means? Very simple. I told you, any command, number one, you have to do operation. You have to do something. I want to add, okay? So you have to tell me, what do you want to add? I want to add this byte plus this byte, right? So you have to tell me where your data should come from. Also, you have to tell me the result, where I have to store the result. That's what we call operand. So operands means you have to tell me the source in this operation. I need data. I want to, for example, you tell me to divide. You have to tell me what data I have to divide, what data. Okay. Also, you have to tell me where I have to store the result. So this is operand. So again, so operand means you have to tell. It's not enough to tell me operation add. It's not enough. You have to tell me what I should add. Also, you have to tell me where I have to store the result. So that's what operand is telling us. So operand should tell the source and destination of the data. Where is the source? Where is the source should come? Where the data should come from, and where I'm going to store the result. Okay, and this all the kind of operands we have. Your data can be inside a register. For example, and I can say inside the register, or your operand can be a memory location. For example, I want to add this number in the location 1000. Okay. So again, we have three types of operands. Number one, it can be a register, it can be memory location, or it can be immediate value. Okay. What do you mean? So register means the number is inside here, right? This is the number I'm going to add. Memory location, so it should be here in this location. Is that okay? What do you mean by immediate value? Immediate value, it means a number. For example, I want to add register A should equal register A plus number 20. Okay, so this is what we call immediate value. So the data is not inside the register, it's not inside memory, it's a fixed number. Okay. So what I'm going to teach right now, and that's what I'm going to spend maybe in the whole lecture today, is in any assembly command, if your operand is register, how we are going to write it? If your operand is memory, how we are going to write it? If your operand is immediate value, how we are going to do it? Okay, so that starting from next lecture, I'm going to start teaching operands. I'm going to start teaching instruction. I'm going to just use the operands here. So that's what I'm going to start teaching right now. So, but I think I have some details here. What I'm saying, guys, here, for example, look here, guys. I want to do something like that. I want to add register A. That means the content of whatever in register A, whatever is stored in register A, register A is storing 20, 30, 40, whatever is there, whatever in register A, I want to add number 20. Then I want to store the result in register A. Okay. So this is a destination, these two sources. So I have two sources. One source is a register. The other source is immediate value. Immediate value, it's fixed at number 20. You understand what I'm saying? So that's what we call immediate value. And then I want to store the result in here. That's okay. Same thing here. I'm teaching. Okay, here. If you say if you want to do something like that, A should equal A plus B. That means I want to store the content. I want to add the content of register A to the content of register B, and then the result I want to store it in A. So the source of the data is A and B. The operation is addition, and the destination is A. So these are operands. Is that okay, guys? I'm just elaborating here. I want you to understand any instruction has to tell me operation and operands. And for operands, we have three operands. It can be immediate value number, or it can be content of a register, or it can be content of memory location. Okay. Now, this is another example. I want to add number 20. So this is immediate value number 20 to the content of memory location 1000. So whatever is there, whatever is stored there. So this is the source of the data. Then I want to store the result in register A. So this is how it should work. I'm going to get number 20. Then I'm going to add whatever in location 1000, whatever the number there. And then the result is going to go to A. Is that okay? Another example, it can be something like that. I want to add A to immediate value 20, and then I'm going to store the result in a memory location. So it should work this way. So I'm going to get number 20. This is immediate value. This is a register operand, and then the destination is a memory location. Is that okay, guys? Okay. Now I'm going to start now teaching. So now you should understand for operands, we have three types of operands. Okay. Your data can come from a register. It can be immediate value. It can be memory location, data stored in a certain memory location, right? What I'm going to teach right now, how you are going to write it in assembly. If your data is immediate value, how you are going to do it in instruction in assembly. If your data is a register, how we are going to do it. If a memory location, how we are going to do it. That's what I'm going to explain right now. Okay, so let's do one by one. Let's start with immediate value. Okay, if you mean this is immediate value, how can you use it in instruction? Very simple, very straightforward. All what you have to do, guys, you have to put the bound sign or hashtag or the bound sign before the number. That's it. So if you put hashtag and then a number, so you mean this is immediate value. Very easy, very straightforward. Is that okay? If you don't put hashtag, as I'm going to explain later, this means something else, right? So if you mean I want to add a fixed number, immediate value, you have to put hashtag. Is that okay? Very easy. For example, I'm giving you some example. Keep in mind, I didn't teach instructions yet, but I'm gonna just for now, I'm gonna use a couple of instructions, but I'm gonna explain later in details. What I'm teaching right now, guys, if you mean immediate value, how you are gonna write it in instruction. If you mean this is a register, how you can write it. If you mean this is a memory location, how you are gonna do it, okay? So I finished the first one, this very easy one. All what if you mean this is a number 20, you have to put dollar signs there. Sorry, you have to put hashtag this one. So for example, now we have load instruction. I'm gonna teach this load instruction later. So load instruction actually are gonna copy immediate value or memory location to one register. In other words, if you want to do something like that in C language, register, whatever the register is, register should equal immediate value, or register should equal memory, the content of a memory location. That's what you have to use load. Okay. Anyway, I'm gonna teach an instruction later in details, but I need this instruction for now to explain how can you express operands. So here, for example, if this is an assembly instruction, this instruction is saying load register A with number 20. So when you see this one, it means it's number 20. It's not memory location. It's number 20. That means after you execute this instruction, if you go to register A, you should find number 20, because this hashtag means this is number 20. Is that okay, guys? One more thing you can hear, someone can tell me this 20 is decimal. It's decimal. Yes, it is decimal. Can I put hashtag and then I put here $7F? Yes, you can do that. Can I put hashtag and then I put %? Yes, 11101. Yes, you can do that. Is that, you understand what I'm saying? So the prefix should tell what this number is. Is this number hexadecimal or binary or whatever? However, hashtag should tell me this is the number, immediate value. It's not a memory location. It's not register. Yes.
What happens if we put an incorrect number
Yeah, for example, you are saying if it is a byte and then I put hashtag 700, for example, and that's what you mean, or what you mean something else? For example, it's a byte. In a byte, you should not write 700. It has to be shorter than 700. That's what you mean? Or what do you mean by? I think, okay, you know, there are two types of errors. There one error, we call it syntax error, okay? And this easy ones. So the code warrior can catch this error, okay? Other errors are called logical error. You know, logical errors are difficult. For example, in your program, you should do addition and you did subtraction. So the program is gonna run, but I'm gonna get wrong result. So everything is okay, the instructions are okay. You got what I'm saying? I didn't try to do that. You can try and tell me what's gonna happen. But I guess this is a very easy case. That's a very easy case. I think the code warrior is gonna catch this error. It's gonna give you error. It's gonna tell you this is wrong. Okay, I think so. Because this, for example, I can say hashtag 3AF. This is wrong, right? Because this is without a prefix. I mean, this is a decimal number. This cannot be decimal number, right? I think error like that. I think code warrior. I didn't try it, but my guess or my expectation, code warrior should be able to catch it. Okay. So, okay, guys. So here, when I say load register A with hashtag 20, I mean here I want to copy number 20 decimal to A, right? However, if I say load register B, okay, hashtag $20. So after you execute this instruction, if you go to B, you will find number 20 there. Okay, guys, any questions? Conclusion. As I told you, we have three types of operands. It can be immediate value, it can be memory location, it can be a register. So if you mean this is immediate value, in any instruction I'm going to teach later, you have to put hashtag. That's it. You have to put pound sign, and then you put the number here, and you have to use a correct prefix as well. Okay, after the pound sign. Is that okay? Easy. Okay, this is the easy one. Now let's move to For example, just I have more examples here before I move to the next one. For example, if I say load x is a word, right? So here I can write a word number. So I can say hashtag $3AF2. So that means because of the hashtag here, this value, this is a number. So after you execute this instruction, if you go to X, you should see this value, okay? Because it's a fixed value. You will see later, if you remove the hashtag, that means it's a memory location. So that's what I'm going to explain later. So if I don't put hashtag here, that means it's a memory, and this is the address of a memory location, right? So anyway, very simple. Hashtag means it's a number, right? Number, okay? Number two, operand can be a register. I want to add register to register. I want to multiply register by a register. Okay. When I add register to register, I mean I add the content of a register. Register is a container, guys. Register like a variable. It's a container. So it means I'm going to add whatever there. You got what I'm saying? So it means the numbers I have to do the operations on are stored in the registers. Okay. Anyway, so number two, if your operand is a register, how we are gonna write it in the assembly instructions? That's easy. All what you have to do, you have to write the name of the register. That's it. For example, let's see example. We have an instruction I'm gonna teach later. This instruction is called transfer. This instruction actually, as I'm gonna explain later, should copy a register to register. You copy register. For example, it's something like as you did in C language, when I say A is equal to B. You know what this instruction is doing? What happened in this instruction? That means I want to copy the value of B to A, and the old value of A is gone. For example, so if before I execute this instruction, if A is storing 20 and B is storing 30, so after I execute this instruction, A should be 30 and B should also be 30, because this instruction you are going to copy B to A, right? As I'm going to explain later in this course, we don't have equal here in assembly. So we don't have equal in assembly. Instead of equal, you have to use an instruction, right? Like this one, transfer. So transfer instruction, as I'm going to explain later, it should copy a register to another register. So now, if I mean my operand is a register, how I can do that? That's very easy case. All what you have to do, just to put or just write the name of the register. For example, if I say transfer A comma B, what it means? It means I want to copy A to B. So that means B should equal A. We don't have this one in assembly, guys. I'm keep repeating because I know most of the programming language, they have equal like this one. We don't have equal here in assembly. And instead of equal, we're going to use instruction. Okay. So here also, if I say transfer X comma Y, that means you copy X to Y. Is that okay? So again, that's also very easy case. So now, guys, I told you, let me say what I explained. Any instruction I'm going to teach later, we are going to use three operands, so three types of operands. Number one, immediate value. And if you mean it's immediate value, you have to put hashtag before the number. Very easy. So once you put here this one, this means this is immediate value. Okay, this number one. Number two, if your operand is a register, you are gonna write the name of the register, something like that: A comma B, X comma Y, B comma A. So here you have to, if you mean it is a register, we're gonna just use the name of the register. Is that okay? The third case, and I'm gonna elaborate in the third case, in case of memory. Okay, if your operand is memory, right? So how I'm gonna express it in assembly instructions? That's what I'm gonna explain right now. Okay. If your operand is a memory location, to do that, there are two main approaches. The first approach, we call it direct or extended. The second one, we call it indexed. Indexed or pointer. Is that okay? So there are two ways. If you mean it is memory, okay? Indexed. And under indexed, as I'm going to explain right now, we have 3 cases. So let us go through them. So again, there are 2 approaches. Okay, one way we call it direct or extended. The other way indexed, and indexed here is used in case of using a pointer. Is that okay? So first, however, in both cases, yes, there are 2 different approaches, but in both cases, you have I should be able to get address, right? Right? Because for memory, if I want to read a location, you have to give me address. Yes. So in both cases, at the end, I should be able to get address. In order to read a location in memory, I need the address. If I want to write to a location in memory, I need address. But we're going to do it in different ways right now. We're going to do it in different ways. Okay. So let's start one by one. So let's start with the first one here. This one is called direct or extended. Okay. In case of direct, guys, or extended, okay, we do it this way. All what you have to do here, just to give me the address. For example, I can say here, load register A $20. What this one means? It means, as you see here, guys, it means I want to copy the byte at the location 20. So 20 here is address. So I want to write a byte at location 20. I'm going to store it in register A. Most of the students are good. I'm gonna elaborate here in this case because I know we have many cases here. I know most of the students are confused here. If I say load register A hashtag 20, or I say load A 20, big difference between the 2 cases. Big difference. Once you see this part here, that means this is not memory. Once you see hashtag, I'm not going to read anything from the memory. It has nothing to do with memory. I'm going to write number 20 in register A. Number 20. Is that okay? However, without hashtag this way, that means this is address. And I want to write a byte in this address, store it in register A. So what's going to happen? Because this is memory. So I'm going to read location number 20. I'm going to read a byte from there, store it in register A. Very easy, very trivial. So if you mean a number, or if you mean a memory, in both cases, you have to put a number, right? So here you put a number, and here you put a number. The only difference is here you put hashtag. Okay. So if you see hashtag, that means it's a number. It's not memory, right? If there is no hashtag, that means this is address. So I'm going to read a byte from there. Yes.
And the same case, what's the byte?
Sorry, it's again?
In the same case, like you're loading something from the
whatever is there, whatever is stored there. Okay, that's your question. So I'm gonna take whatever is stored in location number 20, whatever is there. So okay, whatever is stored there, because this memory location like a container. Okay, for sure there should be, before I use this instruction in the previous instruction, I should have wrote something there. What I'm saying? So this memory location like a container. I'm saying whatever is there. Okay. Any question, guys? Okay. So let me have more example because I want to understand this one very well before I move to index it here. So again, it's the same example I have just taught right now. When I say load A 10, there is no hashtag. That means number 10. So after you execute this instruction, okay, that means I'm gonna read a byte. I'm gonna read a byte from the location 10. So what's gonna happen here, guys? I'm going to read the byte here from this location. I'm going to store it in A. So I can say A should equal the content. When I told you before, when I use a bracket, a square bracket this way, I mean this is an address and I want to store the content of this address in register A. However, if you put hashtag, so after you execute this instruction, A should store 10. Okay, guys? Any questions? Okay, let's have more example. We have an instruction, we call it to store. So again, don't worry too much. Don't worry about the instruction because I'm going to teach all of them later. I'm just using 2 instructions just to teach operands. How can you express operands? Okay. Load, you are going to read immediate value or memory location and store it in a register. A store should copy a register to memory location, or memory location should equal register. So let's have this example. When I say this, guys, this way, store register A in the location 2000. What this instruction is going to do? This instruction, whatever in register A, I'm going to store it in location 2000. Is that okay? If I do this, it doesn't make sense. It's wrong if I do something like that. It's wrong, doesn't make sense. Why? Because this instruction, I'm going to store the content of register A in immediate value. Immediate value is not a container. It's not something I'm going to store in it. It cannot be a destination. The destination, it has to be a register or it has to be a memory location. Destination means I'm going to write to a register to a memory location. Okay, so for sure there is no way you put here. This one only has to be memory. Is that okay? But for load, because I'm going to read, it's okay to become immediate value or it's okay to be memory, right? So here number 10 here is the byte stored at number 10. Any questions? Let's have more examples. So now what I'm saying is, I just want you to understand, if you mean a number, you have to put hashtag. If you mean a memory location, and this is the address, you should not put here hashtag. Okay. So if I see something like that, so that means it's a number, but this is from a memory location. Is that okay, guys? Okay, let me tell you something also here. We are going to use it all the time. When I say load A 1000, okay, that means I want to read a byte from 1000, put it in A. That means if I go to location 1000, whatever is there, I'm going to read the byte from there. I'm going to put it in register A. Is that okay? Okay. However, if I say load X, register X 1000, okay? Here, I'm going to read the word. Here, I'm going to read the byte. But here, I'm going to read the word from 1000, put it in X. Okay, yes, a word means two addresses. Yes, this one and the one below. Yes, automatically. But I don't need to say 1000 and 1001. Just tell me the beginning because automatically I'm going to take the next one. Right? So what happened here in this case, I'm going to take these two, 1001 and 1000 and 1000. I'm going to take these two and then I'm going to store them in register X. Is that okay? How we are going to store them? As I said before, the first one is going to be the most significant. The second byte should be the least significant. Is that okay? I know, just let me finish this. I know you should be confused right now. Why? Because let's agree on one thing before we move forward. We already agree, once you see 1000 this way, without hashtag, that means it's memory. We agree on that. Okay, done, right? However, this 1000 here, this is address. It can mean I'm going to read byte, or it can mean I'm going to read the word from 1000. And if it is a word, that means 1000 and next one 1001, right? So the question is, how can you know? Because if you look at the two instructions, you just here write 1000, you just write here 1000. So how can I know if I'm going to read the byte or I'm going to read the word? How I can know? Simply, you can know from the instruction itself. So every time I teach an instruction, I'm going to tell you this instruction is going to work on a byte, or this instruction is going to work on a word. You got what I'm saying? So how can you know from the instruction itself? So when I teach load A, I'm going to tell you this instruction is going to read the byte and store it in A. When I teach load X, I'm going to tell you this instruction should read the word. So whatever I put there, so I'm going to read the word from the location 1000. When I say, also, I know this is confusing, so listen to me. When I say, and you got it, when I say I'm going to read the word from location 1000, I mean 1000 and 1001 because we agreed from the very beginning, every location will store only a byte. So I don't mean I'm going to read a word from one location. No, but just to make it short, I don't need to say 1000 and 1001. Just give me the beginning address. And when I read the word, automatically I'm going to get the next one. Okay? Yes. You have any questions? Yes. Yeah, you can know from the instruction. So one instruction is going to read the byte from location 1000. The second one is going to read the word from location 1000. Is that okay? So how I can know later for any instruction, okay? How I can know you are going to read a byte or a word from the instruction itself. Okay? So every time I'm teaching instruction, I'm going to tell you this instruction for a byte, this instruction for a word. Any questions? So when I say 1000, it can mean a byte or it can mean a word, right? It depends on what instruction you have. So I'm going to have some more examples here before I move to the next one. So when I say, guys, here, load A 1000, what it means? Very easy. There is no hashtag. This means it's a memory. I'm going to read a byte from memory, put it in A, and this is the address. Keep in mind, if it is a memory, you have to give me the address. Memory means you have to tell me what location, right? In this case, I just give you the address, which is 1000. This is the location. So I'm asking you to read a byte from the location 1000, put it in A. However, if I do something like that, this is false. This is false. What you want to do here, I want to store 1000, number 1000, I want to store it in register A, which is false because 1000 needs a word, not a byte. 1000 needs a word, not a byte, which is false. I can, this okay. It's okay to do this way. So for example, I can say load register D. Do you remember register D, guys? Register D was a word, okay? So this one is okay. But what is the difference between this and this one and this one? Here, because of the hashtag, this is a number, immediate value. It's not memory. So this one, I'm going to store 1000 in register G, right? Here, this is a memory location. I want to read my operand is a memory, and this is the address. So I want to read the word from this location, store it in register G. Is that okay? And remember, register D had two parts. You remember B and A. So what's going to happen is that we have 1000 and we have 1001. So I'm going to read these 2 bytes, 1000 and 1001. What is the order? How I'm going to store them? I explained it before. The first one is the most significant. It's going to come to here. The next one is going to come to here. Is that okay? So I'm going to read the word from here. The first one is the most significant byte. The second one is the least significant byte. When I store it in register D, as you know, register D is actually B and A. So that means location 1000 is going to come to A. The content of location 1001 is going to go to B. Any questions? Okay, that's what I have just explained. When I say load A 1000, I'm going to read the byte from 1000. Is that okay? Number 2, when I say load register G, or we have load X or load Y, all of these registers are words. So I'm going to read words. I'm going to store them in G or X or Y. Okay, guys, starting from 1000, which means 1000 and next one, 1001. Any questions? Okay, so here 1000, I'm going to read the byte from here, put it in A. I'm keep repeating 1000 and 1001. That means I'm going to read these 2 bytes. So the first one is the most significant one, and the second byte is the least significant byte. Okay. Another example for store. I told you store. You are going to store a register in memory. So this instruction, I'm going to store register A in the location 2000, byte and byte. When I say store X, when I teach this instruction, I'm going to tell you this instruction work for words. That means when I say store X, in location 2000. So actually it's 2000 and 2001, right? So this is a word and this is a word. How we're going to do it? Again, the most significant byte has to go to first here. The least significant byte is the second. Okay, any questions? Okay, the last thing I want to teach here before I move to the next topic, what I want to teach here, guys, you told us this kind of operand, we call it direct or you call it extended. So why you call it direct or extended? What is the reason? It's not a big issue, but I just want to, just in case you are confused about why you use two different words, I'm going to explain. Just if your address is between 000 and 00FF, we call it direct. Okay. If it is more than FF until FF, if your address in this range, we call it extended. Okay. Just a name. This is because in case of direct, your address byte should be enough. It's a byte should be enough, right? Because it's 00 until FF. But here, extended, your address needs a word. Okay. But anyway, just a name, but everything I explained to you before, like when you say everything I explained to you before, same thing for direct and extended. It's only, so for example, when I say 20, memory location 20, so this is direct. When I say 1000, it is extended. Okay, that's it. But it's everything else is the same. It's not a big deal. Okay, any questions? Let me tell you the conclusion before I move forward. The conclusion is what I'm teaching today, guys. I told you, okay, any command, you have to tell me what operation and you have to tell me what operands you have to use. I told you we have three types of operands. Your operand can be a memory location, it can be register, it can be immediate value. I told you for any instruction I'm going to teach in this chapter, if you mean your operand is immediate value, you have to put hashtag to, okay, to tell this number is not a memory, it's a number, okay, immediate value. In case of a register, you have to put the name. You have to use the name of the register. Okay, so I want to copy register to register, register to register. In case of memory location, if you mean this is a memory location, I told you I'm going to teach two things. One thing, we call it direct or extended. And this one is used if you want to read or if you want to write to a memory location. Okay. So and already it's not pointer. So you already, this is the memory location. Here, in case of indexed here means, listen to me. Indexed here means we are gonna use a pointer here. Tell me what do you mean by a pointer before we move forward. Tell me how we are gonna use a pointer and what you mean. I'm gonna tell you what I mean. Pointer mean, guys, first pointer like PC. You remember PC? PC was a pointer. Okay. Point, but it's gonna point at an instruction. It's a register, and this register is storing an address, right? That's why we say it's point. It's point because it's storing address. It's pointing at a certain address. Okay. It's the same thing here we are gonna do in this course. If you wanna read, usually if you wanna read an array, if you wanna write to an array, you have to use pointers. Pointers are used if you wanna read or write arrays. So what this means and how, I'm gonna tell you how. For example, here, okay. Let me give you example just to understand what pointer means because we have different types of pointers we are going to use right now. All of them are used for to read or write arrays. So first I want you to understand the concept of pointer and how we're going to use it. Don't worry if you don't understand now very well. We're going to use it all the time. If you have array and you want to read or write arrays, we're going to use pointers. I'm going to tell you what is the idea. The idea is that assume this is an array. In this array, we have location 1000, right? So this is, we have something 3A, for example, and we have 1001, we have 1002, all the way this way. So every byte here is one element. So this is element 0, this is element 1, element 2, and so on. Is that okay? So if you have an array, how later we're going to read this array. What is the main idea? I'm going to tell you, here comes the idea of a pointer. What we are going to do, I have to use a register as a pointer to store the address. This register usually we are going to use X or Y. Register X or Y. Is that okay? What is going to happen if I want to read an array? Number one, I'm going to store the beginning address in X. For example, I'm going to use X, but also it's correct for Y. Is that okay? So here in the very beginning, I'm going to store it X. So assume this is share is a byte. And this is the array. If I want to read this array, the way you are going to do it, as you will see in this course, the beginning address 1000, I'm going to store it in register X. Is that okay? So if I am register X, so I'm pointing at here. I'm pointing here. So what do you mean by pointing? I mean the value I'm storing is the address of this byte, 1000, for example. So in the beginning, in the pointer, I'm going to store 1000. So the pointer is pointing at this byte. Is that okay? Then, as you will see right now, I'm going to write an instruction to read the byte at the location pointed by X. So there is some way, as you will see right now, I want to read the byte at the location pointed by X. So now I can read the first element. And then I'm going to increment X. Now X is pointing at the second element. Then there is some way, as I'm going to explain right now, I can read the byte pointed by X. Okay, what this means? It means I want to read the byte at the location stored in X because X is a pointer, right? Then I'm going to read this one. Then increment X. Then I'm going to read the byte pointed by X. Increment X. And so this is how I'm going to scan array using pointers, okay? To do that, there are, so all what I'm going to explain right now, it's about pointers, okay? Here, to do that, there are 3 different ways we can use. The first way we can use, as you see here, I'm going to explain them in details, okay? Constant, comma, X or Y. Again, I told you in this course, we're going to use register X or Y as pointer, okay? So this is the first way you can do it. You can put here a number, constant number like 0 or 1 or 2, comma, so 0, comma X, 1, comma X, 2, comma X. Is that okay? So it means this, it's a pointer, okay? The other way, I'm going to elaborate now, but let me give you the big picture before I move forward, okay? Because for pointer, if you want to read a memory location using a pointer, there are 3 ways. If it is not a pointer and you want to read a certain specific location without a pointer, you can use this approach. You just write the address here, okay? But here, the address, I'm not going to give you the address directly like this case. Here, the address is stored in a register X, in a pointer. That's why it's called a pointer, okay? Anyway, the other approach is I can do something like that, A, comma, X, use A, B, or D, comma, and use X or Y, okay? So for example, you can say A, comma, X, B, comma, X, D, comma, Y. So this is one operand using pointer. Don't worry, I want to give you the big picture. Now I'm going to give you the details, but you should understand all of these are pointers, okay? That means, remember, what I'm explaining here, this is memory. So you have to tell me what address you want to read, right? So we're going to use 2 ways to do that. One way, I'm going to just give you the address. I want to read location 20, right? Here, the location is stored in a pointer. You got what I'm saying? In a pointer. So if you want to know the location, which location I want to read or write, please ask the pointer, right? If the pointer is storing 7000, so I'm going to say, I want to read the location pointed by register X. So I'm going to go ask X. X, where are you, X? I'm at 7,000. So I'm going to read 7,000 because it's a pointer. So here, I just give you the address directly. Here, I put the address inside the pointer. And why you do that? Why you don't just give me the address? Simply because this one used if you want to read an array. So what I'm going to do, I'm going to put the address in the register. And then after I read one element, increment X. Increment X. Increment X. That's how I can read array. You got what I'm saying? So If you want to use a pointer, there are different ways. So this is, as I'm going to elaborate, this is one operand constant, a number, comma x. I'm going to tell you what it means. But for now, if you see something like that, you should understand this is one operand, a memory location, one operand. Or A, B, D, comma X or Y. If you see something like that, that means it's one operand, it's memory, right? Where is the address? I'm going to tell you where is the address. Anyway, also, if you see something like that, also a number 1 or 2, comma X, and then so this one is similar to this one here, 1, comma X, for example. However, here we use plus or minus. Here we don't use plus. So how they are different? Okay, I'm gonna now explain in details, but this is the big picture. Conclusion, okay? If you see a number this way, that means this is a memory. I want to read or write to memory. We agree with that. If you see one of this format, that means it's a memory, and this is constant, comma X or Y, right? If you see A, comma X, B, comma X, D, comma Y, something, one A, B, D, one of these, comma, one of these, so this is one operand, okay? I'm going to elaborate tomorrow, just for now. If you see number, comma X, and there is plus before or after, or minus before or after, that means this is also memory. So any format you see here, once you see it in any instruction, that means it is memory, right? We're going to read a byte or a word from a location in memory, okay? So let me elaborate for now, okay? Okay. I'm going to start one by one, okay? But we agree that they are going to be used any one of the 3 cases, in indexed cases or pointer cases. Any one of these cases should be used to read or write arrays, because all of them are pointers, but just different ways, okay? So let's start. So here what I'm saying here, the first case, you are going to put a constant, a number. This number can be positive or negative, comma, you put X or Y, okay? So the first question you should ask, where is the address? Because remember, I'm reading from memory, I'm writing to memory, so you have to give me address, right? So here, for example, if you say 2, comma X, so what's going to happen here, guys? I'm going to take whatever in X plus number 2, and this will be the address. So I'm going to read a byte from this address. Okay, so what happens here, guys, when you do something like constant, 0, 0 or 1 or number, comma X or comma Y, if you see something like that, that means this is a memory, right? My operand is memory. If I want to write to this location, so I'm going to write to this address. If I want to read from this location, I'm going to read from this address. Which address? The address is whatever in X plus number 2. This is your address. Is that okay? Or if you put here 0, so plus 0. If you put 1, plus 1. Okay, so how is this useful? Okay, so I'm going to tell you how it is useful, but let me elaborate here. Look here, guys, what I'm saying. In any instruction, I'm going to teach later, when you see something like that, 1, comma X, I know this topic usually confusing to students, but we're going to use it all the time, so you will be familiar with it. So when I say 1, comma X is this way, guys, that means this is one operand, and this operand is a memory. I'm going to read from memory or write from memory. For example, when I say something like that, load register A 0, comma X. When you see something like that, what it means? It means I want to read a byte. From a memory location and store it in A, because this is memory, right? Which memory location? It's actually the memory location is stored at X plus 0. X plus 0. That means X plus the constant number. This should give me address. For example, if X here is storing 7,000, so that means I'm going to read the location number 7,000. I'm going to get whatever is there, put it in A. Is that okay? Remember, we are reading from memory. You have to give me address. what I explained before. In case of direct, I'm gonna tell you I wanna read location 2000. So this is the address. Now I'm gonna explain different ways to give you the address in an indirect way, using pointers. Why we do that? Because that's what we're gonna need when you read or write arrays. Okay, so let's see. Same thing here, guys. If I do something like that, load register D 1, X. Once you see something like that, guys, this format, once you see this format, that means you want to read the word from memory and you want to store it in register D. How did you know this is a word? From the instruction itself. This instruction for a word. So here I'm going to read a word from memory. Which location in memory? You have to tell me which location. Yes, because this is a pointer. I have to calculate it. So the location should be the value stored in X plus 1. So I'm going to add the value stored in X plus 1, and this is going to give me the address, whatever is there. So for example, if this is if this one is, for example, 3000, so I'm going to read the location 3001 and 3002. So I'm going to read these two locations. I'm going to store them in D. Any questions? Okay. So now, for example, yeah, some students ask me, yeah, before using this instruction, should I put something in X? Yes, for sure. Before you, as I give you one example, this is exactly what we're going to do later. What we're going to do later, guys. In my point, I have to initialize my pointer with the beginning address of the array. Okay, I'm not going to say just read the location pointed by X. No, number one, you have to initialize X with the memory, with the beginning address. So X is here. Then I'm going to read, increment X, read again, and so on. Okay, so you have to initialize the pointer. For sure, you have to initialize it. For example, I'm going to write some instruction to initialize X with 1000. Is that okay? And then I'm gonna read the byte. I'm here because this is load A, so I'm gonna read the byte from this memory location. A byte, I'm gonna put it in A. Okay. So which location? Again, so several things confusing student here. Number one, when you see this format, this means one operand. It's not two operands, it's just one operand. Okay, this number one. Number two, when you see this format, constant, comma X, that means this is a memory location. We are gonna read from a memory location. Okay. Number three, you need to ask yourself, okay, now you want to read the byte from a memory location. Which location? Which address? It's actually the address should be X plus 1. Because X is storing 1000. So I'm gonna read I want to read the byte from the location 1001, and then I'm gonna put it in A. Is that okay, guys? I know some students also confused here. Listen to me. If you pay attention and listen to focus, you are not going to be confused. See what I'm saying. When I say 1, X, this instruction is not going to change X. This when I calculate the address. When I calculate the address, guys, X is storing 1000. I want to calculate the address, so I'm gonna add 1 because that's what you are asking for. I'm gonna add 1 plus X, and then it's gonna be 1001, and this will be the address I'm gonna read, or this is the address I'm gonna write to. Is that okay? But I didn't say you are gonna increment X. This instruction is not gonna increment X, right? That's why before you execute this instruction, if X is storing 1000, after this instruction, X is still storing 1000. In the quiz, I'm gonna make a quiz, but maybe I'm not gonna make it this week. I'm gonna make it next week because you have a very short time to study this topic. So I'm gonna make a quiz. In this quiz, I just want to make sure you understand that this instruction is not gonna change X. So what I'm gonna do, I'm gonna give you these two. I'm gonna tell you X is storing 1000. I'm gonna execute this instruction. So after I execute this instruction, what should be the value of X? Okay, I'm just testing you. I want to make sure you understand this instruction is not going to, this instruction is going to take whatever is put in X plus 1. And this will be the address. I'm going to read. Right? Any questions? The second case, which is almost very similar to this case. I told you in the first case, if I go back here, yeah, in the first case, you put here constant, comma, X or Y. Okay. For now, I want you to understand what this means. When you see something like that, what it means, right? Later, don't worry. Later, I'm going to explain how can you use them to read arrays, because all of these are going to be used later to read arrays. This stuff. Okay? So, by the way, before I forget, guys, okay, let me tell you something here. Before I look here, and you remember if I do something like that, as we did in the last lab, I can say sum dc.b org 1000. Please understand what I'm saying now. Sum dc.b 7, for example, or 0, as we did last time. Okay. If I write in my instruction here, listen to me. When I say load register A 1000. Okay. So I told you this one last time. I told you the location 1000. I'm gonna call it sum. Location 1000. I'm gonna call it sum. Right? Similar to what you did in C language. Integer I, and the I should have a physical location in the memory. This is the same thing. So sum should start from 1000. Okay. Okay. I told you last lecture, every time I use the word sum in my program, sum is going to be replaced by 1000. What it means? It means if I say, and that's actually what we're going to do. If I say load register A sum, okay, that's it. So it's similar to what you did before. If you have integer R, you just use R, right? That's exactly what we're going to do here in this course, guys. What we're going to do, you define a variable. For example, variable is put to sum, right? And then you can all the time you can use the word sum. That's it. You don't need it. So if you want to, if you already know sum is equivalent to 1000. Okay. If you want to use 1000 this way, okay, it will be exactly similar to this one. So these two cases are exactly the same thing, are exactly equivalent, right? However, this case is much easier for us in programming, much easier. Why? Because this is easy case. You have one variable. What if your program has 10, 20 variables? Should I remember this variable in location 1002, 1003, 1007? Why I do that? Why overcomplicate it? It's too simple. All what you have to do, just use name. Load A sum. That's it. Load A speed. Load A temperature. Just use name. That's it. And what's going to happen is the compiler is going to replace the name with the address. When it is converted to machine code, the compiler is going to replace the name by the address. Is that clear, guys? What I'm saying now is that if you already define a variable, okay, you can just use the name this way, okay? For example, load is sum. That's it. Okay. If you want to use it, already you know this variable is at this location. If you want to use this one, it's totally fine. Okay. But this would be difficult if you have too many variables, because we don't like numbers. We want to use names instead of numbers. So what's going to happen when you use the name of the variable sum, speed, temperature, I, whatever, the code word is going to replace it by address. Any questions? So this is easier for us. Anyway, so now I'm going to move. I told you we're going to move to the next case for pointers. Yeah, I told you this is the first case, guys. Once you see constant number, comma X, okay, I told you this is one operand. Okay, and here this is a memory location. You are gonna read a byte or read a word from this location. This depends on the instruction you are using. Okay, so you should ask yourself, how can you calculate the address? How can you get the address? Because if I want to read or write a memory, from memory I have to get address. Yes. All what you have to do, I'm gonna add the value of x plus the constant here. But this one does not change x. So x will be the same. Just when I calculate the address, I'm gonna add 0 plus x. But I'm not gonna change x. This will give me the address. Once I get the address, I'm gonna go there, read or write. Right? Here, you don't need to do any calculation to get the address. I just give you the address. You don't need to do any calculation. Here, in all these cases, you have to do calculations because I'm using a pointer, right? So you have to calculate the address. Here you don't. Here you don't need to calculate the address. Okay? So I'm gonna get whatever in x plus the constant here. Okay? Don't worry how we are gonna use it. Don't worry, we're gonna use it all the time. But I want you now to understand. Once you see something like that in your program, this means memory, and you should know where is the address. Okay. Number 2, I can make it this way: a comma x, b comma x, d comma y. Okay, so I can use one of these register a, b, d, x or y. I can do this way. Okay, so again, if you see something like that in your program, for example, I say load register a comma x, or b, a comma x. If you see something like that, what it means. So if you see this format, this one of the formats of the memory. So once you see a number without hashtag, that's memory. Once you see something like that, that's memory. Once you see something like this is memory. Is that okay? So that means I'm gonna read the byte from this location and store it in register B. This is number 1. So number 1, once you see this format, that means it's memory. Number two, what address? What is the address? Actually, here the address should be x plus a. Okay, so I'm gonna get whatever in x, whatever in a. I'm gonna add them together to get the address. Is that okay? This should be give me the address. But tell me how this can be useful. And this instruction is not gonna change a or x. So I'm gonna add to get the address. I'm gonna add x plus a. But I didn't say I'm gonna store the result in x. I didn't say that. What I said, in order to get the address of the location I want to read or write, I'm gonna get whatever in x, whatever in a, add them together to get the address. I didn't say I'm gonna store the result in x. I didn't say that. Is that okay? Tell me how this can be useful. You are telling us a pointer is a memory. So how something like that can be useful? I'm gonna tell you how. Look here, guys. X is here. X, I have to initialize x. X is pointing at element number 0, the first element. Is that right? So x plus 0 is going to give me element 0. X plus 1 is going to give me element 1. X plus 2 should give me element 2. X plus 3 should give me element 3. Is that okay? That means if I keep x, if I put the initial address in x, the first address I put it in x, and then whatever I put in a, it's going to be the element number. So x plus 10, I'm going to get element 10. You got the idea? So now x is going to be initialized with the first address. A is going to tell me which element you want to read. Okay? The beginning address plus 7, I'm going to get element 7. That's how we're going to use it later. Is that okay? Anyway. I know this topic is somehow students usually confused in this topic for some time, but we're going to use it all the time so you will understand anyway. Okay, so that's what I explain here, guys. You have to use one of these register A, B, D, and you have to use X or Y. Okay, so for example, I can say B comma X. That means I'm going to read the byte from memory. Once you see something like that, that means it is memory. Okay, which address in memory? I'm going to add B plus X. Then I'm going to get the address. And then we're not going to change B. We're not going to change X. I just got the address. Once I got the address, I'm going to read a byte from there. I'm going to put it in register A. Any questions? Okay. Let's see some examples here. For example, if this is an array, guys, X is going to point at the first location. I'm going to initialize X with the beginning address. Then if I say 0 comma X, so this is another approach. Again, without using A or B. What I'm saying, if I initialize X here, X is pointing at the first location. When I say 0 comma X, I'm going to read element 0. When I say 1 comma X, because it's gonna be x plus 1. So I'm gonna read the location set element 2, element 3, element 4, element 5, and so on. Okay, I can do this way, or as I have just explained right now, I can do it a comma x, and I put the initial location in x. In b, you can put the element number. So for example, I can put 0 or 1. So you can make it a constant number this way, or you can put it this way, whatever you like. So now you understand the idea. So x is pointing at element number 0. So 0 plus x is gonna give me this guy. 2 comma x is gonna give you element number 2. 10 comma x is gonna give me element 10. 99 comma x is gonna give me the element 99. Yes.
So you put a letter there. You have bytes from that location.
Which byte you mean? So which letter you mean? X?
No, A. So
A.
A in that case, are we using the location or the actual
Okay. X is a register, A is a register, right? So what I'm gonna do, A is a register, X is a register. Is that okay? Number one, you should understand when you see something like that, this is a memory location. Now, that's number one. You don't think about it. This is one operand, it's a memory location. Now you should ask yourself, what is the address? What's the address? The address, microprocessor is gonna calculate it. How it's gonna calculate it? I'm gonna get whatever in A plus whatever in X, whatever in A. I'm gonna add them together, and then I'm gonna get the address. You got what I'm saying? So register X is storing the beginning address. Register A is storing the element number. I want to read element number 200. So X plus 200. You got what I'm saying? Yes.
So what happens if we already have something?
Yeah, that's a good question. Always students are confused. If I want to read a location, I'm not going to change whatever there. So if this location is storing 20, I'm going to read 20, so I'm going to copy. it. I'm not going to change it, right? However, if this location is storing 20, and then I want to write 70, so I'm going to overwrite whatever there. So whatever there is gone. So I'm going to overwrite it. So after I write, it's simple, man. This is similar to what you did in C language. For example, if I is equal to 2, and then after some time I say I is equal to 10. What is the value of I? 10. What is the old value? It's gone. So I is a container. Right? I put it 2. Then after some time, after some instruction, I put 10. So it's gonna should store 10. The old value is gone. You overwrite it, right? So it's the same thing. I is like a memory location. It's like a register. Containers. All of them are containers. Is that okay? Anyway. Okay, that's enough for today. See you tomorrow. As I told you last time, as I told today, we're gonna have quiz tomorrow on the directives. Okay, so we need to study directives. Okay?